All right, well, welcome back. We are now going to talk about the elimination method. Remember, we have three methods for solving systems of equations. We've got the graphing method, we've got the substitution method, and now we're going to talk about the elimination method. They're all great. You need to always use the one that you are asked to do because different situations are practice opportunities for different methods. So you're going to probably find that you find one method you love, 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 and you want to do everything that way. If you're given a choice, feel free. But if you're not given a choice, I'm sorry, but you do need to do the method that's required. But for now, let's talk about the elimination method. Now, the elimination method basically means we're going to take the two systems and we're going to add them, and with any luck, something will drop out. Well, we don't really hope for luck in math, right? We do things algebraically to make things in a certain format so that we can solve them. All right, and that's what we're going to do here. So I see that we have the system x plus y equals 5 and negative x plus y equals 9. And if you treat that sort of like a big addition problem, all right, I'm going to add, okay? When I do that, I get 0 plus 2y equals 14. So in this case, we're very fortunate because now I can ignore the 0 and I have 2y equals 14, and if I divide both sides by 2, y is equal to 7. So I've already solved most of the problem. Okay, here's my y equals 7. And then, like before, I can go ahead and take that and substitute that into either equation, and when I do, I will find the value for x. And then I see that my solution is negative 2, because that's what I got for x, and 7. Got to put it in parentheses because parentheses tell us we have a point. And then again, the checking part is not the solution part. It's just going to be a way where you can be sure that your answer is right. And if I put negative 2 in place of x and 7 in place of y for each equation, I should get a true statement. If I don't, I just made a mistake, and that's okay. It just tells me I have to go back and fix it. But in this case, it does work out, and negative 2, 7 is correct. All right, so now I'm looking at another problem, and I am told to solve the system, and let's say I'm told to use the elimination method, and I'm going to put in my big plus. Nothing adds to 0. If nothing adds to 0, there's something I must do first to force it. All right, now what I also see is some fractions here, and you know, fractions, I don't mind them, but they're not that easy to work with. So if I can use a method to clear the fractions, that's legal, I will do it. And I did that here on the second equation, and I'm now calling it equation 3 at the bottom. And what I did, this is kind of a big idea because you're not going to want to mess around with a fourth and a third if you don't have to. But if I multiply each and every term in that second equation by 12, how did I pick 12? Well, 12 is the least common denominator of 4 and 3. So if I multiply everything by 12, things get to cancel. Those denominators cancel, and I end up with 3x plus, well, 12 times a third is 4. 3x plus 4y equals 12. Remember, I've got to multiply 12 by that 1. I've got to multiply 12 by each and every term. And when I do, I have this new equation, 3x plus 4y equals 12, which is much easier to work with. So I'm going to use that for my system. I'm going to start here. All right. So I'm going to still go ahead and add, big plus, I'm going to add, and I still see nothing's dropping out, but it's going to be a lot easier than if I had to work with fractions. So it seems like I had an extra step, and isn't that terrible? Not really. It's just an extra step to make my life a lot easier. All right. So what I want to do is get either the x's or the y's to drop out if I were to add them. So if I had that top equation multiplied through by 2, I would have negative 4y plus 4y, and the y's drop out. That's what I'm going to do here. But I do want to point out that if you thought, you know, I really want those x's to drop out, all you would have to do is multiply the first equation by negative 3, because then I'd have negative 3x plus 3x, and that's 0. So if that's the first thing you thought of, it's perfectly fine, and it will work, and you will get the same answer. And if you don't believe me, I can live with that. Go ahead and try it on some scratch paper. But let's go ahead and move forward with multiplying the first equation by 2, and when I do, I get the y terms to drop out. And remember, when I say multiply the first equation by 2, I mean multiply each term by 2. And when I multiply each term by 2, I get 2x minus 4y equals negative 12. Then I go ahead and add, and I get 5x equals 0, x equals 0. Don't be afraid of 0 as an answer. 0 does not mean undefined. It just means 0. 0 is a number, and it's okay. Now you know by now we are not done. I'm going to take that 0 and pop it into either equation, and I will find y. Okay, when I do, I've got my point, got my xy, I've got it in parentheses, and then I want to make sure I do the check, even just on scratch paper, and make sure that that makes a true statement for each equation, and in this one you will find that it does. All right, here's another system, and remember that I'm going to skip over some examples in this video, but in the PowerPoint presentation and doc sharing you'll see all of them because it's this very PowerPoint. But if I multiply the first equation by 2, coincidentally, I will get my x terms to drop out, right? What's interesting though is the y term drop out, and I get 0 equals 0. So what happens when 0 equals 0? When you get 0 equals 0, or when you get anything like if you were to get 4 equals 4 or some true statement, that means that there are an infinite number of solutions, and if you were to graph it, the lines would overlap, okay? And if you were to work that out and get a false statement like 0 equals 4 or something like that, it would be that they are parallel and there is no solution. Remember, x equals 0 or y equals 0, that's fine. But something like 4 equals 0, that's not fine, that's false. Parallel because they don't intersect. Hopefully that makes sense. All right, so here's our thing about the weird situations. That's not very mathematically accurate. We should call them special cases. I call them weird. I like getting 1 point of intersection. Anything else is weird. So if they completely overlap, every point on one line will be on the other line as well. And if I get a false statement, there is no solution. All right. Just quickly, we'll take a couple of minutes to talk about at least the setup on some word problems, and then I'll let you look in the PowerPoint presentation for these in great detail. But remember the first example we did on the very first video about the t-shirt example. Now that t-shirt example, we had the setup, and it looked like that. And we agreed, hopefully we all agreed, that guessing was not a great idea. So we're going to go ahead and now solve the system. And when I do, I look at that and think, well, I can't get anything to drop out if I add them, but if I multiply the top equation by negative 8.25, I'm going to get the x's to drop out. And when I do, I'll let you look at the math, I get y equals 11. Pop that in for either equation, I get x equals 41. Here's a common mistake I see on word problems, and it does result in a deduction of points, at least a point. If you just said 4111, that wouldn't tell me anything. Think about if you were presenting in front of your colleagues, and if you said, okay, 41 and 11, they would stare at you, and they don't know what that means. All right, so always put it in context. That's the whole reason for math, is because it's got some applicability, okay? Besides the logical thought processes that we're learning, we also actually get some applications we can get out of that, out of math. And if you just say 41 and 11, make sure you add to it. So if you don't want to do a whole sentence, at least say, here's the whole sentence, but at the very least say 41 shirts at 8.25, 11 shirts at 11.50, something like that, just the label at least. So you do want that. All right, mixture problems. It helps to see a little diagram. So if you are having to mix some 30% acid and 50% acid to get a mixture that's 35% acid, and you want 20 liters of it, how much of each do you need? At first it might seem like you don't have enough information, but you do. And we're going to set up a chart. Charts are great. Don't skip the charts. Remember, you can go to the PowerPoint presentation to look a little more slowly, but it's going to look, all mixture problems are going to kind of look similar. So I've got T is the first, F is the second, and they both represent the number of liters of each. I know it's a total of 20. I know my percentages, I've got that there. And so the amount of acid is 30% of the number of liters of the first plus 50% times the number of liters of the second equals the mixture 7. All right, 7 is just 35% times 20. Remember, we don't work with percents. We have to make them a decimal first. So we pop that decimal point left 2 to get the decimal form. Then we've got our two equations, and it is just as easy as what we did a second ago. All right, so you would multiply the top by, let's say, negative 0.5. That would get the F's to drop out. I get my answer for T, substitute to get F. I've got my point, but I want to say it in the sentence if I can, or at least the label. That means there should be 15 liters of the 30% solution and 5 liters of the 50% solution to get the mix that they wanted. All right, motion. If you know distance equals rate times time, you can isolate any of those variables. Okay, so if you've got a motorboat that took 4 hours to make the trip down with a 5-mile-per-hour current, and the return trip, you're going against the current, took longer, 6 hours, what's the speed of the boat in still water? Okay, I'm going to set it up like this. My distance doesn't matter, it's the same either way. But my rate downstream is faster, so it's the rate, R is the rate of the still water, so it's the rate plus 5, the current, and then upstream I'm fighting it, right? I'm going to go slower, so it's going to be the rate minus the speed of the current, R minus 5. The time is 4 and 6, we're told that. And so if distance equals rate times time, and each distance is the same, I can go ahead and set those rate times times equal to each other. So what you see here is distance equals distance. Rate times time equals rate times time, and then you can just solve for R. Okay, and you do again, you get your value for R, and that's how you want to present it. You don't want to just say 25, you want to say 25 miles per hour at least, okay, if you don't want to say the whole sentence. All right, so solving motion problems, it's helpful to draw a diagram for all of these. Make sure you answer what was asked. Great tips. So thanks for joining me. Hopefully you saw all 3 videos. Ask me questions. I am here for you, and I always want to help. So please ask questions, and thanks for watching these videos, and I hope you have